Good afternoon, everyone. My name is Jaisane Asioli-Macquarie. I'm the Executive Officer of the Western Beef Association. Welcome to our Better Hay and Silage webinar. I would like to start by acknowledging the traditional custodians in the land in which we are transmitting this webinar today, and also where you guys are joining us from, and pay my respects to past and present elders. I would like also to acknowledge the funding we received for this project from the Future Drought Fund through the federal government, and also the collaboration from the State Department of Primary Industries, which is hosting the webinar today, and assistance from the Southwest NIM. We have Peter Clifton joining us today, and he's going to be handling the questions at the end. The presentation is going to be done by Dr. Martin Staines. Some of you have met him in some of the Better Hay and Silage workshops, and also Ruminate. And we were going to be looking at the samples that were submitted by participants from the Better Hay and Silage workshops we had. Every participant received a voucher. They all said in their evaluation sheet that they were going to submit it, but we only had about 35% submitting. But nevertheless, it's great information because it's very scarce of the variation and distribution of quality of hay and silage in WA. So it's really good to have a look at what's around and learn from these results and get some tips to improve in coming seasons. So we have a fair bit to cover today, so I will leave you here. Enjoy the presentation. This is going to be recorded, and I will circulate the link afterwards for if you want to watch again or sort of point to someone else. That is also going to be available on our website, and make the most of it and ask heaps of questions. Thank you.
Good afternoon, everyone. My name is Martin Staines. I've been asked to prepare the analysis and the presentation that you're going to listen to today. I have worked with Jaisane for a number of years. I work in nutrition of cattle, both dairy and beef, and I've also been the co-developer of the Ruminate software that some of you may be familiar with. I want to start with just reminding people of the cost of making conserved pasture, either hay or silage. I've got some typical figures up at the top of the slide here, where round bale hay is typically around 40% more expensive than the pasture it was made from, and round bale silage is typically double the cost of the pasture it was made from. So both are expensive to make, especially silage, and we'll come back to that point towards the end of the presentation. Those costs, of course, vary depending on the scale of your operation, whether you use contractors, etc., etc. So these are typical costs, but costs will vary between farms. And when you make silage or hay, you always end up with a product that is of a lesser quality compared to the pasture it was made from. And that quality is expressed in various ways, and we'll look at them in more detail soon. But typical figures for energy content of hay are, this is Australia-wide, not just in the WA. For hay is 8.6 megajoules of ME, hopefully you're familiar with those terms, and silage 9.4. But for both of those, there's a wide range in energy content. And likewise, there's a wide range in protein content for both silages and hay. And there are other quality indicators we need to look at, and we will do that in the presentation. So feed quality is important, and we've encouraged people to test feed. As Jaisane said, unfortunately, only a minority of participants in the hay and silage workshops actually submitted samples. So the total samples we've analysed over 2 years is 34 hays, 30 silages and 2 straws. And so we want to look at some more detail for both of those, starting with hay. So the 34 hays can be broadly categorized into sort of grassy hays, if you like, mixed hays, ryegrass hays or ryegrass clover hays. That was 21, I think, samples out of the 34. And then there were also about 13 cereal hays, 12 cereal hays and a veg hay. And so we can work out what the mean nutritional parameters for those hays was, but I think it's more interesting to actually look at the best and the worst. So out of the 34 hays, I've summarized the average on the top line and also the bottom 5, the worst 5 on energy content, and the top 5 hays on energy content. And I've highlighted with a red box the key differences between them. So you can see that although the average energy concentration of hays was 9.3 megajoules per kilogram of dry matter, the bottom 5 were sitting at 8.3 and the top 5 were sitting at 10.2 megajoules. And that's a big difference, and we'll come back to that difference in just a minute. But in keeping with the differences in energy content, there is also a commensurate difference in the fiber content, the NDF content. So you can see that the bottom 5 hays had an NDF content of 65%, which is quite high, whereas the top 5 hays had a much lower NDF content of 52%. So that also means that animals consuming that top 5 hay can consume more compared to the animals consuming the bottom 5. And so there is a higher energy content per kilo and more kilos can be consumed, which then translates into a significant increase in production, and we'll come back to that. And then also in keeping again with the increase in energy content, there is also an increase in the sugar content of the hays. The bottom 5 hays had on average 9% sugar. The top 5 hays had an average of 22% sugar. All other parameters were very similar between these hays. The protein content did not really differ all that much. And starch, fat and ash, that's the total mineral content, was also very similar between these hays. So the main difference was the energy concentration, and then the flip side of that is the fiber content versus the sugar content. So if we look a little bit closer as to what is the implication of the difference in energy concentration for animal production. And the first slide I'm showing you is a prediction of what live weight gain we can expect for 300 kilo Angus steers. This line is a predicted response line. And I've shown there what the bottom 5 hays with 8.3 megajoule per kilo can be expected to achieve, and that's a predicted live weight gain of 0.2 kilos per day. So with these steers we're fed the hay and nothing else. And then the second group is the top 5 hays with an energy concentration of 10.2 megajoules, and we can then predict that animals fed this hay would be achieving a live weight gain of 0.7 kilos per day. So that's a substantial difference, which is driven in part by the difference in energy content and in part by the fact that animals can eat more of the better quality hay. Then I also have an example for sheep. And I've chosen, in this case, ewes in late pregnancy or lactation. These are 60 kilo ewes with a condition score of 3 and a single lamb or a single fetus. And what's shown on the axis here is the U life weight loss, because in all cases we can work out that these hays would result in a life weight loss during late pregnancy. The hay with the lower ME content is shown in yellow or orange, and we can predict that ewes in late pregnancy fed the hay would be losing about 180 grams per animal per day, whereas if they were fed the hay with 10.2 megajoules of energy, they would be losing about 60 grams per animal per day in late pregnancy. That's the last 3 or 4 weeks. And then once the animal is lactating, that's in the first month after lambing, those differences are larger. The poor hay would result in a life weight loss of 240 grams per animal per day. With the good hay, that life weight loss is limited to 120 grams per animal per day. So again, there's substantial differences between the two hays in what animal performance we can expect to get. But it's also indicative that even the good hay may not be able to sustain a high level of animal production during late pregnancy or in lactation. And then there's another point I want to come back to, which applies to all the hays, and that's the protein content. We'll have a look at that in a minute. First, I want to look a little further into the differences between the hays and sugar content. So this graph is plotted for both mixed grass hays and for cereal hays. The ME content of the forage plotted against the sugar content of the forage. And you can see there's a reasonably good relationship in general between ME content and sugar content. As the ME content goes up, the sugar content also goes up. But you can also see that there's a reasonable separation between the cereal hays shown in blue and the mixed grass hays shown in orange. It's not absolute, but there is a degree of separation there. The cereal hays tend to have a higher sugar content, which is partly responsible for the higher energy content on average. And there's another factor that comes into explaining the differences in forage ME between the different samples that we analyzed, and that is the stage of plant maturity at which the forage is harvested. And this graph you may have seen before for those of you who have participated in Grazing Matcher, a very useful program. If you haven't, you're encouraged to participate in it. We're looking for participants at the moment. What is shown here is that when the plant is actively growing and green, we can typically expect an energy concentration of about 11 megajoules per day, which would be sufficient in cattle to sustain a rate of life weight gain of 1 kilo a day. And then as the plant matures, goes into late vegetative stage or starts to get into flowering, then the energy concentration starts to drop because the fiber content of the forage starts to increase. And so as the plant matures, energy concentration drops to 10 megajoules and then to 9 megajoules. And as a result, animal performance will also drop as shown here. And then finally, when the plant is in full seed set and starts to dry of itself, then quality drops to even lower levels of 7 to 7.5 megajoules or less, meaning that this can only support animal maintenance of life weight gain, or if energy content is less than that, it will obviously result in a life weight loss when this product is fed to cattle or similarly in sheep. So the stage of maturity at which hay of silage is harvested, whether or not there is lots or very little emergence of seed heads, has a big impact on the quality of the product that you're going to make. But in all cases, protein in hay was low. 40% of hays had a protein content of less than 8%. which is the minimum you require for maintenance, and only 20% of hays had a protein content above 12%. And so animal performance is going to be restricted to a significant degree by the low the low protein content of the hays, regardless of the energy concentration. And so in that case, the protein content needs to be addressed by providing additional protein, and that of course can be achieved in various ways. Options are to include legumes in your crop or pasture, where that's feasible, or supplement with a legume hay. In the case of grass pastures, provision of nitrogen fertilizer will increase in general the protein content of the silage or hay that's going to be made. Or the alternative is to supplement animals with a source of protein, either lupins or canola meal, or with caution, supplementation with urea, which is risky, but it can be done successfully if managed carefully. So these are some of the options that would need to be considered in order to achieve reasonable levels of production with the hays that we've presented here. So then next let's look at the silages, and 30 silages or silage samples were presented for analysis, and they were largely made up of grassy type silages or mixed silages of various kinds. There was also one silage specifically mentioned ryegrass clover as the base, one with ryegrass oat, and then 4 oat silages were also presented. And as far as we know, these are all baled silages. As far as we know, no pit silage samples were presented. But having said that, that question was not specifically asked on the submission form that was presented with each sample, and so we have to go by what we think we know about the samples. As far as we know, they're all baled silage. That point's important. I'll come back to that a little later. So then if we look at the same nutritional parameters again, that's energy, protein, fiber, etc., then there's another factor that comes into play for silage, and that is of particular importance is the dry matter content. And so again, I've presented here the mean for the 30 silages and also the bottom 5 and the top 5 silages based on energy content. And we see a very similar picture to what we saw with hay. There's a big difference between the bottom 5 and the top 5, of a similar magnitude as what we've seen in hay. But in addition to that, and also important with silage, is a difference in the dry matter content. When silage is too wet or too dry, it's going to affect silage quality. And so we can see that the bottom five silages had an average dry matter content of 55%. The top 5 silages had an average dry matter content of 43%. The target is for baled silage is between 40 to 50%. And so you can see that dry matter content may have been a contributing factor to the lower energy content in the bottom 5 silages compared to the top 5. Protein content was not really different between any of the silages, but it was higher than it was in hay, on average 12% protein. And then again, in keeping with the difference in energy content, we can also see a difference in both the fiber content, the NDF content, and the sugar content. So again, a similar picture to what we saw in hay. The bottom 5 hays have a significantly higher fiber content compared to the top 5 silages, and the reverse, the bottom 5 silages have a lower sugar content compared to the top 5. And both those factors contribute to the difference in ME content, and will again also impact on the amount of feed that can be consumed. When there's a higher fiber content, we expect animals on average to eat less compared to a product with a lower fiber content. There was no difference really in fat content between the products, and the ash content is interesting because once ash content or total mineral content starts to exceed 10%, that's indicative of contamination with soil. And contamination with soil in silage is a real risk, much more so than in hay, because silage is wet and soil particles can stick to the moisture product. And so the bottom 5 silages had an average ash content of 11%, which indicates that there has been a degree of soil contamination, which not only is unpleasant to eat, but it will also lower the energy content of their product. So that's the standard nutritional values for silage, but there are also parameters to consider with regards to fermentation quality. And that's summarized in the next slide. How well did these silages actually ferment? Now, again, we've already talked about dry matter content in the previous slide. So I'm going to talk about silage pH, and then also the ammonia expressed as a percentage of total crude protein. These are all quality indicators of silage. I'll come back to that in a minute. The total silage acid content, that's the percent of dry matter that comes from silage acids. Then the percentage of silage acid that was present in the form of lactic acid. Lactic acid is the main silage that's responsible for pickling the silage, for reducing the pH to preserve it. And then also relevant is what is the acetic acid content in the silage. It's again an important acid that contributes to the pickling of the silage. Acetic acid is basically vinegar. And then there's a very undesirable acid called butyric acid, which is the acid you can smell when butter goes rancid. And that silage, a high level of butyric acid is indicative of poor fermentation. So let's have a look at the figures. For baled silage, the target pH is 4.5 to 5, and the top 5 silages had an average pH of 4.6, so at the lower end of that target range, which is great. The bottom 5 silages had a pH of 5, which is at the higher end of the target range, but on average they were still on target. Then the ammonia expressed as a percent of total crude protein, that's indicative of how much protein breakdown is occurring in the silage during, or has occurred in the silage during fermentation. The target is for that to be less than 10%. And unfortunately, both of those were, well, the bottom 5 silages were sitting above that, and even the top 5 silages were sitting at the upper end of that target. So not as good as we would have hoped. Then the silage acid content, we would like that to be more than 5% of the total dry matter content of the silage, and none of these silages on average met that criterion. The bottom 5 silages, only 2% acid, the top 5 silages 4.5%. So not ideal. And then the next parameter is the percent lactic acid. That's the percentage of the total silage acid that's present as lactic acid, which is the most acidic of the acids occurring in silage. That needs to sit well below 100%. If it doesn't, it's indicative that fermentation is not complete. And there were in fact 4 samples out of the 30 that did have a level of 100% lactic acid. So 4 silages were basically sampled too early. And so ideally we would exclude them from the analysis, but they have been included here. So there was a difference between the bottom 5 and the top 5, 56 versus 73%, but the more important figure is the total silage acid content. There was a substantial difference between the bottom 5 and the top 5. Acetic levels were very similar, and they are more or less on target. The target is 1 to 2%, so they're all in the range. But unfortunately, the picture was different for the butyric acid content. So as I mentioned before, it's an indication of poor fermentation gone wrong. And on average, 11 out of the 30 silages, so 1/3 of the total samples submitted, had a high butyric acid content. That's more than 0.2%, and that's not good. So it indicated that 1/3 of the silages were poorly fermented. If we then look at the bottom 5 and the top 5, 1 out of the 5 in the bottom 5 was poorly fermented, and none out of the 5 top 5 silages had high butyric acid content. So they had all fermented well. If we examine that silage quality in a little bit more detail, let me explain the next slide. It's a bit full. What I've plotted here is the 30 points, blue dots, for silage dry matter content versus silage pH. And the target zone for dry matter for baled silage is 40 to 50%, which is indicated by the yellow square box in the middle of the graph. And then the two red lines indicate the upper and the lower target zones for pH. And so if you overlap the yellow square box with the boundary set by the red lines in the graph, you can see that actually very few points of the 30 silages were within that ideal target zone. So overall, about 1/3 of silages had the correct dry matter content. So they were all within that yellow box. 1/3 of silage samples roughly were too wet, and 1/3 of silage samples were too dry. So there was poor control of dry matter content in the silage when it was baled. So that's a significant factor that will impact on quality. And then separately, about 1/3 of silage samples were of the correct pH, and 2/3 of silage samples were off target. So if you combine those two together, if we now bring it back to that zone in the yellow box between the red lines, it's only about, if you're generous, about 20 to 25% of samples that sit in that zone. And so 75% of samples sit outside that zone. And that's a factor that's contributing to the relatively disappointing result for silage quality in this study. And then another relationship I'm showing here is silage pH plotted on the x-axis, the bottom axis, and total silage acids plotted on the vertical axis. And there too, again, I've shown the target zone with the yellow box. And you can see again that very few samples actually sit in that target zone. And you can also see there's a strong relationship between silage pH and total silage acid content. And so the aim is for that to sit above 5% of dry matter in the silage, and you can see that there's only about half a dozen samples that sit above that line, and only about 5 samples that sit in the correct silage acids versus silage pH target zone. So again, the majority of silages sit outside that zone, and then the low pH combined with the low silage acid content again contributes to the poor pickling performance that we've seen in many of these samples. So you can then also look at in a little more detail at what did silage type have to say about silage quality, and I've condensed it a little bit more. I'm focusing on on dry matter content, energy content, pH, and total silage acids, or total VFA. So for the 15 mixed silages, they were on target for dry matter, an average ME of 9.6, pH of 9.4. That's all okay, but the total VFA was disappointing at only 3%. For the 4 grass silages, or the 9 grass silages if you include ryegrass in that as well, dry matter content okay, ME okay-ish, pH okay, silage acids little not fantastic. Then there were a couple of, there was one ryegrass clover silage that did well, but it was very wet, 31%, and as a result, ME was a little disappointing. Ryegrass oat silage, one sample, too dry, too low on pH, and ME of 8.8, which is less than what we would like. And then on average, 4 oat silages, a little on the dry side, 52%, ME 9, again a little less than we'd hope, pH okay, but total silage acids also low, and that again may have contributed to the relatively poor performance, or the poor energy concentration in these silages. So participants completed a submission form where a number of questions were asked, including was the crop affected by rain, did you use a tedder, and how long was the crop out in the field. And for silage, we broke that down into less than 2 days, 2 to 3 days, or 3 to 5 days. Unfortunately, we only had 13 forms out of the 30 samples where that information was available, and the great majority did not do any tedding. There was only a couple of samples where tedding was practiced, but if we break the results down by wilting day, there was 3 samples, silage samples, that were wilted for less than 2 days. 5 samples were wilted for 2 to 3 days, and 5 samples were wilted for 3 to 5 days. And remember that almost all of those did not use a tedder. There were a couple of crops affected by rain, and then the tedder was used. But on average, for the rapidly wilted material, dry matter content was too low, 35%. It did result in a product with an ME of 9.8, which is not too bad, pH 4.3, which is good, total acids good, and acetic acids okay. So despite the low dry matter content, it still ended up being a reasonable product. And then silage was wilted in contrast for 3 to 5 days. Dry matter content 55%, so it was wilted for too long. The material was too dry for pit silage. ME 9.4, pH 4.7, total silage acids, VFA 2.7, and acetic acid 0.9. So just not quite as good a product, partly caused by the higher dry matter content. It was wilted for too long. Unfortunately, we don't have that information for all samples. So silage, does it stack up? Based on the 30 silage samples that we analyzed here, there were too many poor silages. Only 1/3 of the silages were in the target zone for dry matter. Many too wet, many too dry. 1/3 of silages were poorly preserved with a high butyric acid content. 4 of those silages were too wet and 5 were too dry. Too dry reduces the effectiveness of compaction during baling, so that more air is included in the bale, and so it will take longer for the product to pickle, and it doesn't pickle as effectively. Then also I mentioned there were several silages that had too much ash, too much soil contamination. That could be caused by cutting too low, or if tedding is applied, tedding too aggressively, but often cutting too low, below 5 centimeters, is a problem there. And then, yeah, 4 silages were sampled too early. We do need to allow at least 4 weeks of ensiling before sampling a product for quality, right, in silage. So finally, I want to look at the difference between hay and silage. And here I'm just comparing the overall average for the 30 silages and the 34 hays. So on average, silage ME was only 0.2 megajoules above that of the average hay made in this study. And that is much lower than the average difference between silage and hay Australia-wide, where the difference is about 0.8 megajoules. So rather disappointing for the improvement in energy content of the final product. Silages were significantly higher in protein, on average 12.5% as opposed to 9.7% for hay. And however, the NDF content was virtually identical, the fiber content, and in all cases it was rather high. So that's indicative that the material it was made from was relatively mature. There was a difference in sugar content between silage and hay, 9 versus 15%, and that is explained by the fact that during ensiling, part of that, well, 2 factors. No, let me focus on sugar content. During ensiling, sugar is used as an energy source for bacteria to produce silage acids. So, in other words, the sugar in the forage is consumed during the pickling process. So I'm actually surprised how high the sugar content in the silages is. I had expected it to be lower. And then, yeah, the difference on average in ash content we've already talked about. So if I can sum up my key messages, first of all, there is a big difference between the worst and the best products in this study, and that applies to both silage and hay. And their management is a key factor. Cutting height, stage of harvesting the product, and effectiveness, the speed with which the product is baled and made, at the correct dry matter content, and with the correct attention to detail. So, yeah, management is a big part of why the worst and the best silages and hay differ as much as they do. In my view, the increase in silage quality that was seen here was not enough to justify the increased cost on many farms participating in this study. And we started the talk by emphasizing the increase in cost, where silage is typically double the cost of the forage it was made from, whereas hay is about 40% more expensive than the product it was made from. So there's typically about an $80 per ton dry matter difference between silage and hay. And in my view, the extra feed quality that was achieved here in the silage did not justify that extra cost. But I'm up for debate on that. In my view, silage making requires more attention to detail to be cost effective. The correct dry matter content is an important factor, and then also rapidly getting it to the correct dry matter content as soon as possible. And so the practice of tedding, which was rarely used in this study, is a factor to be considered. And finally, I think this analysis has shown the value of testing your feed. It then tells you what you have and what you can expect to achieve from your product. If you have a poor quality feed, then target animals that have a lower requirement. if you have a high quality product, target that to animals that have a higher requirement for energy and protein, etc. Or in the case of hay, you may end up with a really good hay, but given the average low protein content of the hay, you then need to think about supplementing with protein. That brings this analysis to a close. And I would like to thank Zani for her input and for organizing this study. I think it's been most useful, and really it's, there's not many of these data sets available in Western Australia, so I think it's a great contribution to understanding what's happening with forage conservation. Thank you very much. I'm open to questions. Mr. Chairman?
Yeah. Thank you, Martin. That was wonderful. And yes, thanks to Jasani and Western Beef for the project, because I think it's good to know where we stand, and that there's still some improvements to make, and there still will be continuing workshops under various programs over the next few years at least. So has anybody got any questions or even just comments? Because I think it's useful just to reflect on those numbers, and if anybody has any input into what some of the challenges were, if you did submit a sample, explaining why it might have been low, or maybe where we can make improvements in the future. So any comments or questions? There is one there.
They'll just ask if the results will be shared.
The results will be shared?
The video is being recorded. Sorry, the video is being recorded, and we're going to be looking at putting a summary, a written summary that will be made available. I take the opportunity to mention that there are quite a few videos on helping on the do's and don'ts, and especially monitoring dry matter pre-baling that is available on the Western Beef website.
Okay, and I've got a question from Mark Thomas. So do we have any idea on whether the silage was made by the farmers or by contractors?
We didn't ask that question.
Yep, okay.
I found when we were making silage in previous seasons, I had very little control over when the contractors either cut or baled, and we're totally uninterested about the effect of dry matter and timing of baling.
Yes, it's Janimi. That's a very common problem for people that rely on contractors. The contractor comes when he comes. You have no control over it, weather events, maturity of the crop, etc., and that will definitely. It would be interesting to know, Mark. I would predict that on average, silage made by contractors may, for that reason, be harvested. Well, I have to be careful here. Are there any silage contractors in the audience? It's a hot topic. I was going to say it's likely that you end up with a poorer product, but then on the other hand, they tend to work very quickly, have very powerful machinery, etc., etc. So that may offset that partly. Let me be more cautious, but I'm interested in your experience, Mark. Yep, thank you. Somebody also asked, can we maximize the slides? I thought that was...
No,
yeah.
that's
Okay, good. Another question?
Yeah, so Phil's asked, is there any way to increase ME other than cutting earlier? And I think the tedding was an interesting one. I thought maybe tedding might have been a little bit more common.
Yes, no, in this study it was very, very uncommon. And so it seemed that generally crops were mown and then left in the field until 3 or 5 days later and then baled. There was only one of the 30 silages that was tedded immediately after mowing, and then again a day later. So a crucial factor is, in my view, is to ted immediately after mowing, so that the crop is spread as widely as possible to promote rapid wilting. And then ideally after 24 hours, turn it over again and then bale it at 48 hours. And that's a way to rapidly get to your 40% dry matter. Obviously it varies with the weather conditions, but yeah, tedding is an important factor. Then other ways, I guess the selection of what you grow will have an impact there as well. But yeah, then when you cut what you grow is probably more important than the genetics. So it comes down to harvesting early before plants go into seed emergence, and rapidly getting it wilted. And even in the case of hay, there was one study where hay sat in the paddock for 26 days, one sample, and that's not ideal either. There is deterioration. Even when you're producing hay, there are field losses that will be more extreme the longer the product is exposed to weather in the paddock. So also with hay, getting it in quickly is an important factor.
What?
Yeah, sorry. I was just going to add something that is also sort of the cutting height.
Yep.
Because sort of as I was receiving results, I noticed the ash content, and that's quite usually linked with ME. So it's a combination, because you end up picking a lot of the really sort of mature, or even from the previous years, the stubble, and that tends to decrease quality. But the other reasons are also sort of like by cutting too low, the wilting is not as efficient because you don't get air circulation. So it's there's the old school that by cutting low you actually get a higher volume, and you also decrease weed in the paddock, but there's lots of things that you lose from it. And the other point is that you might also reduce regrowth if there's still humidity for that grass to keep going.
In grass pastures,
so it's a real no sort of cutting too low. So aim to above 5-7 centimeters is the ideal.
Amanda, I'll get on to you in a moment. Just ask one more question regarding that. Is that I guess that conflict between, if there's a little bit of weather around, do you cut when it's at the right maturity and manage it on the ground, or do you wait? Is that a hard sort of trade-off?
It depends on the weather that's coming. If it's a couple of mils, I guess I would wait. But if you for the weather to pass, but if you are facing a big rain event that's really going to increase soil moisture, and it might take another week before you can get on, then you've got a real dilemma on your hands, and you're sort of damned if you do and damned if you don't. And sometimes that can be responsible for a poorer result. So it's going to really cost you, and you have little that you can do to really avoid the impact. But it will have an impact, whatever you do.
And the rain, so if it is a couple of mils, is that going to have much of an effect on hay that's already been cut, or silage that's been cut?
No, a couple of mils probably not. The questionnaire asked for rain events greater than 5 mils, and I would have thought 5 mils is already a reasonable amount, but no, a couple of mils won't be too bad.
Yep. Amanda, I don't know if you want to unmute and ask. You've got a couple of questions there, so.
Okay. So from our attendance at the previous meeting, we've sort of tried to move away from the thought of going into silage and looking more at planting or using protein-based beans or some sort of supplement for the hay. But at the moment, because it's sort of not a popular thing and the people have moved away from some of those products in the market, it's hard to get. It's hard to start, different materials needed for different cropping, machineries for different cropping. So is there to get into this, we're believing in what you're telling us. We want to be on top of giving the cattle the right feed. But to get in and get started on it is very difficult. So just any suggestions or any guidance on how you'd go about doing it?
Who would like to answer that one?
I think that you, from the their point of view, I would think sort of improving clover inclusion might assist with that.
Yeah, so I guess the question then would be, tell us more about what your forage base currently is, and then what opportunities do you have. So it really comes down to sitting down on a one-on-one basis and exploring the options you have. Would veg hay be an option for you? Are you in a cropping zone? Are you in the southwest in a high rainfall zone with pastures? So the answer depends. But I don't think there would be any grants available to support such activities other than joining grazing matcher, which you probably have done already.
Yeah, one of the things that the federal government has indicated that they're extremely pleased, although sort of, we were hoping for a bit better results, but it's everybody has had a couple of challenge years, so we can't sort of achieve everything. But it's it might have been improving. I think it's great to have this webinar today and having discussions, and it's a continuation. So they have indicated that they will be inviting us to apply for extension of this project. I don't know what are going to be the limitations, but it's one of the things we are looking at. There's a lot of things like additives or time of cutting or pasture composition that WA has its unique growing season and its unique soils. So it's something that we are looking at, something that will provide more resilience, but we also need to do some tests. But it might be from a continuation of this grant, but we are keeping an eye out for ways to do it.
Yes.
And
so to support your rolling out of this project and to support your findings, there may be 2 or 3 farms that would be prepared to work with you to sort of get it going, to support, well, we've done this in this area, this is what they were previously, this is how they are now. It supports what we're saying.
Yeah, that's something that sort of basically was partially of the idea once, was to sort of basically get the people that never tested, have their toe in the water, to actually recognize the value, but was also to build this database. So we are in a position to approach funding bodies and saying, this is where we are, we need to improve this area and that area. I don't know if Peter would like to comment on some of the work that they are looking at perennials. That might be something that might help with the protein level. So with the Southwest NIM current.
Well, yeah.
Thank you.
No problem.
Thanks, Amanda. Well, I was more thinking about us supporting more hay and silage events for the next 3 years. So I'm glad that there's still, demand and need for that. I was more thinking about, like, the protein levels were quite low, Martin, in general. So is there, how do we get more protein? Is it, people not using nitrogen, or as we've found, is it issue with clover not nodulating? Are there other options? Like, say, you've mentioned vetch, but are there other options to put into, a mix that might fix a bit more nitrogen?
Yeah, and that solution will depend on your production system, where you are, what your soils are, etc., etc. So it's hard to generalize, but the solutions that we outlined there are all options. And so in your case, supplementation with lupins or canola or something like that could maybe a more cost-effective option. You just need to consider that. But even dairy farmers that use a high level of nitrogen, or for those dairy farmers that do in the southwest, often silage protein levels are a problem as well. This is grass-based silages, because the high level of long-term high level of nitrogen use, the clover tends to be outcompeted by ryegrass, so you end up with relatively low levels of clover in your sward, which then means low levels of nitrogen, of protein in your silage. So it's a common problem.
Grazing is something that can be used up to a certain extent to control a little bit of that mixture. But whereabouts are you, Amanda?
Here on the south coast of Manglanup, where the Big Blue silo is.
Right.
Heading towards Esperance, but an hour out.
Yep. Yeah, no, we're definitely sort of looking into it, but yeah, it's just a question of attracting funds. We'll keep you posted.
Yeah, we appreciate it. Thank you.
Is there any more questions? We've got a few more minutes for questions, Jasani.
Yeah.
Yeah, Phil Hull.
Yep.
I've got a question.
I should have said actually before, if anyone wants a question, there is a button down the bottom where you can just raise your hand. Hopefully you can see that.
Oh,
But yeah, no, you're fine. Phil, go ahead.
I didn't catch quite what Rick said, but when you harvest, is it best to harvest when it is vegetative or when it is late green?
Well, sorry, are you talking grass-based silage? Yeah.
I'm growing oats, for example.
Oats, okay. Well, with oats, with cereals, there is a trade-off between energy content versus amount of product made, and that's a topic that we cover in the silage workshops. Where are you, Phil?
We're in Marble Up, just about 25 k's west of Albany, on the way to Denmark.
Okay. So these topics will be covered in more detail. If you like, I can send you some information one-on-one, because there is, for grass pastures, there's a very clear rule of cut at the very early stages of ear emergence. So normally before 10% ear emergence. For cereal hays, the rules vary because there is a trade-off. You have to be careful there that you get both quantity and quality. You want to try to find the optimum, and that differs between the species as well, whether you grow oats or wheat, for example. So if you like, if we can get your contact details, I can send you. Yeah, I can send you some more information on that.
That would be fabulous, Rick. Our crop failed. The reason you didn't get a sample from us last year is that it was such a bad year, and our little area was declared a drought area, and our I just couldn't come and cut raking and rolling what we had. It just wasn't worth it, and just added to the cost, and I spent the money buying in other higher quality hay.
Right. Yep.
And grazed it off. Yeah.
They for those of you that participated in the workshop, just remembered that you've got that big door stopper that you
the silage book.
So the silage, they top for the book, and there is some information on that as well on time of cutting for for pastures, but also for other types of hay and silage. And the other point, just remember, like I keep on making this point, is remember that cereal hays are always low in protein. So even if it's a good quality, if the animal eats and it has a good amount of energy, it always lacks protein. So if you're purchasing, even if it's high quality cereal hay, remember that for lactating, heavily pregnant and growing animals, you will need a protein supplement.
Yep.
Do we have any final questions before we finish up? I think we've got about 1 minute to go. I hope we were working on an hour. Good.
Yeah.
Everyone happy?
Thank you all.
No problems. We'll be circulating the link And also sort of I'll send you a reminder of all the materials that are available from our website. And watch this space. We've got a few more things coming up. Thank you for your time.
Quickly, I've just put it in the chat. So everything that we do is heavily reliant on the membership base that we have. So if you've gained any benefit out of being a attendee at any of the Western Beef events, please join us as a member. So the membership details I've put into the chat. You should be able to just click on the link there and complete. It's not a lot of money, and it goes a long way to allowing us to continue doing what we're doing.
Well done, team.
Thanks, guys. Be in touch.
Thank you very much.
Thank
See
you.
ya.
Thank you.